Hello and welcome to part 3 of this series. This will be more of a workflow demonstration rather than talking about all the technical stuff. How to install ACES. Some software packages do ship with ACES, but for all the others we will have to download ACES manually. So let's just search for ACES 1.1 GitHub. The first option should be the correct one. This will include more than one OpenColor.io config, but ACES will be one of them, and that's the one we're interested in, specifically ACES 1.1. The easiest way to download them is to just simply go to code and download zip. Unfortunately, this will download all of the different OCIO configs, even those that we don't want, but we'll just have to take that hit. After downloading the archive, simply open it with a double click. I have WinRAR installed, but you should also be able to open this without it. Inside the archive, you can find multiple directories. We're only interested in the ACES 1.1 directory. To use ACES, we actually need to extract it. In my case, I'm simply going to create a new directory under the C drive called OCIO and place the directory in here. After that is done, I can close and delete the archive, as we will no longer need it. In here you will find all files necessary to use ACES. Depending on the software you want to use, you might need to modify the config.ocio file. But before we do so, I want to create a backup of it. First step I'm going to take is deleting all the unnecessary color spaces that I don't use anyway. This will help me shorten the list of input transforms available to me in software packages such as Blender, making it much more usable. At the top here you can find all the output transforms, or rather references to the output transforms. The actual color spaces and transforms are all stored under the color spaces tag. If we delete any color space that is referenced up here in the roles and display section, we'll break the OCIO config, so we need to make sure to delete it here as well. Actually, don't need most of these color spaces, so I'm just going to delete them. Color spaces listed here are also mentioned in the active views list, so we also need to modify this one. Software packages such as Blender will always choose the first option in this list to be their default, so let's move Rec 709 to the front. Next, let's clean up our roles section. Instead of using the full names, I'm actually going to use the aliases or nicknames of these color spaces. The nickname for ACES CG is simply ACES CG. I'm not really going to use compositing lock, so I want to later delete this color space. This means that I have to get rid of this role entirely or change it to something else. There's one role that deserves special attention. This is the color picking role. Depending on the software, different color spaces here can be useful or even break your config. Using the ODTs for sRGB or Rec 709 can be very handy if you exactly need to match reference colors, as you can pick them, but apart from that, they can break your energy conservation, since they're applying the ODT in reverse. This means picking any value brighter than 0.8 will, in result, be larger than 1.0 and reflect more light than it receives. Personally, I would not recommend you to use this option. Option number 2 is sRGB texture. sRGB texture is the IDT for sRGB. This means that you're definitely not going to break energy conservation. You're only going to use the color palette available to you in sRGB. There are two downsides to this. 1, you're a little bit limited in the color range. 2, if you need to exactly match your reference colors, well, these values are going to turn out darker in the final output, since the ODT is going to darken your image overall. Option number 3 is ACES CG. The color picking rule will not only be used for color picking, but also for color selection, and this could potentially break energy conservation if you're using it on surfaces, as ACES also includes colors, which do not really exist on surfaces, but only in light sources. To sum it up, if you need to match exact references, use one of the output profiles. If you're planning to select colors for shaders, use sRGB. And if you're using the color picking role to change lights, use ACES CG. Now that we've gotten rid of most of these roles, we can actually move to deleting color spaces that we don't need. I'm going to keep all of the ACES color spaces themselves, but I'm going to definitely delete all the unnecessary input transforms, as I don't own any Arri, Sony, Red, or Canon cameras. As you can tell by the scroll bar on the far right, this document is actually very long, so I'm not going to show you the whole process of deleting all these color spaces. Instead, I'm going to upload the file that I'm using so that you don't have to do this all manually yourself. If you want to use your custom OCIO config with Mari, you will require some additional roles, but I'm not going to add these, as Mari already ships with a custom ACES config. The easiest way to install ACES is through the environment variables. To do this, simply click Start and search for Environment. Then select Edit Environment Variables for your account. This will lead you to this new window. And here, simply click New, name the variable OCIO, and select your OCIO config. To apply the settings, we now need to close this window, pressing OK. Any software package that supports OCIO configs will check this environment variable before launching and use the config accordingly. We can check this easily by launching Blender. While Blender doesn't have a UI, to actually choose an OCIO config, we can easily check which one is being used. To do so, simply go to the render options and then down to color management. We can see now that we're using ACES, and our output device is set to Rec 709. While this is the only option to install ACES in Blender, except for manually swapping out files in the Blender directory, it is not the best option the way we did it. Because now any software that does support OCIO configs will use this file. So if you're working on multiple projects, some of them using ACES, some of them don't, then, well, you're kind of screwed. But don't worry, there is a workaround for that. First, we're going to delete the environment variable again. Let's check if everything worked. We got rid of ACES. The other way to do this is using a modified shortcut to Blender. All we need to do is modify the path found in the properties. To do so, I'm going to use the notepad again. As a first step, we need to copy the line of code that can be found in the video description. There are 3 paths in here, and all 3 need to be correct. The first one is pretty much guaranteed to be correct, as it simply points to Windows' default command prompt. The second one needs to point towards our ACES config. Last but not least, we need to check that we're using the correct directory. To do so, simply copy the start-in location from your properties window. All we need to do now is copy this line and paste it into the target, replacing what was in there originally. This changes the icon of the shortcut to the command prompt. We'll start Blender though, and it's going to use your ACES config. While this shortcut also sets an environment variable, it only does so for the application that is launched using it. This method might look quite complicated, but don't worry. Depending on the software that you intend to use, you might not have to do this anyway. Packages that already ship with ACES or have actual UI elements to select an ACES config will not require you to do this. Out of all the software packages that I use, Blender is the only one that relies on it. However, if you want to use this technique, You can also use it for software packages such as Maya, Mari, or Nuke. Both Nuke and Nuke Non-Commercial do ship with ACES, so it's pretty easy to activate. Simply press S while you're in the node graph to access the project settings. Go to the color section and select OCIO as your color management. Then select ACES 1.1 for your OCIO config. Alternatively, you can use a custom OCIO config. Next in our list, we have Mari. Unfortunately, only the commercial version supports ACES. To enable it, simply create a new project. And under the color settings, instead of using Nuke default, choose ACES. You can then modify the roles that you want to use. If you've created your own OCIO config that you want to use, simply use custom. Let's now take a look at the last piece of software that I want to show you, DaVinci Resolve. After creating a project, click on the gear symbol at the bottom right corner to open the project settings. Go to the Color Management tab. In here you can change the color science to ACES CC or ACES CCT. I'm going to use ACES CCT as that gives the user a little bit more control in the shadows, and I don't need to use the reference for ACES proxy, which is only compatible with ACES CC. After that, I'm going to switch the ACES version to ACES 1.1, as that's what I used during rendering, and as ODT, I want to use Rec 709 again. Additionally, we can turn on Use Color Space Aware Grading Tools. This means that the color grading tools will be adjusted to make it easier to edit within a color space. Let's start with a workflow demonstration now. First, let's verify we're using ACES and the correct ODT. After making sure that is true, I'm going to import a model so that we have actually something to work on. Next, I'm going to import an HDRI. HDRIs are typically not created in the ACES color space, and almost all of them that you can find online are in linear sRGB. So let's either select utility linear sRGB or its alias lin sRGB. This removes the red color cast from the HDRI. Next, let's import some textures. For color maps, you should always use the color space that they were created in. This project was originally not done in ACES CG, so instead of using ACES CG, we actually need to use utility sRGB texture or its alias sRGB texture. This is true for all color maps, such as base color, subsurface color, or emission. Let's import our displacement next. For everything that's not colors, so all data textures, such as displacements, specular roughness, normals, metallic, or anything similar you can think of, we will need to select raw or utility raw. Once you're getting to rendering, it's time to decide your final output format. If you're using any of the standard image formats, such as PNG or JPEG, your output device transform will be applied to your data. If you're using EXRs, your data will stay in ACES CG, and you have the optimum quality for compositing. Using ACES in Nuke works pretty much the same as using it in Blender or Maya. Simply import your material, and select the color space that it is stored in. The output device transform can be found at the top of the screen. If you've used ACES for rendering and stored your output as EXRs, they are also going to be stored in the rendering color space, which would be ACES CG. The sequence though is from a camera, and it's pre-converted to ASUS 2065-1, so that's what I've selected. When you're rendering your sequence, you will get to choose the output color space in the right node itself. If you're using PNGs, I would use one of the ODTs. If you're using EXRs and intend to edit this content in a different software later, choose ASUS CG. Next up, we have Mari. And Mari is a little bit more complex than the other software packages. This is due to the circumstance that all paint nodes and channels can have individual color spaces assigned. When texturing, there are two types of color spaces you're going to use the most. The first one is for color data. For your color channels, it's best to work in the same color space as you're rendering. This, in our case, would be ASUS CG. If you're not working on an ASUS project, it would be linear sRGB, but labeled simply as linear. Automatic did select the correct color space for us this time. But if I want to make sure that we're matching the rendering color space, we can simply do so by selecting Rows, Rendering. Ignore the raw and scalar data options for now, as they're not meant to be used with color data. ASUS only truly works with floating point data, so we at least have to use 16-bit half precision. For raw data, on the other hand, we want to select raw as our color space. Since we've already selected raw as our color space, we don't actually need to tick this checkbox. What we need to do though is tick the scalar data checkbox. What this does is tell Mari to disable the ODT while looking at this layer directly. Raw is what we want to use for all data. This includes masks, but also channels such as roughness, metallic, or normals. If I look at this data node, you will notice that the ODT has been changed to raw in the lower left corner. This is what the scalar data checkbox is for. If I untick this checkbox, it displays our raw data using the ODT, which is not what we want. If we were to create a channel, the same rules apply. And depending on what channel we are working on, we will either have to use raw data with this combination, or our rendering color space if we are working on actual color data. When importing data to paint nodes, be sure to select the right color space. This texture is an sRGB, so we need to use the same. The same is true for importing textures into your image manager, whether that's via drag and drop or the import icon. The ODT at the bottom left is only here as a preview. If we're actually exporting, none of this is going to be baked into the textures. You can see that the color space of the export will still be ASUS CG and not sRGB. The fact that the ASUS ODT makes everything look darker can be especially annoying during texturing. You can see how these white pixels don't really look white, but slightly grayish. This can be especially annoying if you need to match references. As a workaround, you can use the ODT as IDT, but I wouldn't really recommend that, as that can break the energy conservation of your scene. The second way around this would be the reverse, to use the IDT as ODT. By default, the IDT will not be available in the selection list, so you will have to manually edit your config. Making changes to our custom OCIO config won't really have any effect on our Mari scene. For our Mari scene to take effect, we would need to change Mari's OCIO config. Mari's OCIO config can be found in this directory. Now after restarting Mari, we should have the IDT available to us as well. And now white looks like white again. Personally, I don't like this method either, as this creates a rift in the preview of what we are seeing and what rendering will actually see. So I like to keep working using the same ODT that rendering and compositing use. By default, this is set to sRGB, but you might remember that we are planning to use the Rec 709 preset instead. An additional tip would be to include the name of the color space into the name of your texture. Some software, such as Maya, will then automatically set the color space. A few words have to be said about Substance. While Substance Designer does ship with ACES, I haven't really tried working with it yet, so I'm not going to do a demonstration. Substance Painter, on the other hand, currently doesn't even support custom OCIO configs to be imported, so there isn't really much you can do there. However, you can still use Substance if you're rendering an ACES CG, as long as you make sure to select the correct IDTs. This will cause a slight shift between the viewport preview in Substance and the rendered output, but if you want, you can download a custom LUT, which can help you minimize that. Color management, however, does to some degree exist in Substance Painter. You can choose the color space and bit depth for a specific channel in the texture set settings. For the base color, for example, the default is sRGB 8. This means we're using sRGB, including the sRGB transfer function, at 8-bit precision. RGB without S at the beginning would be linear, but, well, 8-bit isn't quite enough, so we choose, for example, RGB 16. If we choose L, it means we're going to grayscale, and if there's an F at the end, we're choosing floating point. These working color spaces are separate from the export though. Our output color spaces depend on the file type and bit depth we're selecting. If we're exporting to PNG, our output will always be sRGB. If we're exporting to EXRs, on the other hand, our output will always be linear sRGB, even if we were working in nonlinear sRGB. Let's now take a look at the last piece of software that I want to show you, DaVinci Resolve. We've set up ACES in an earlier part of the series, so we can start adding footage right away. If we have any backplates that are stored in RAW, just drag them in, and they will already be converted to the working color space. If we go to the color section, we can now still go in here and change our RAW settings. Importing EXRs rendered in ACES CG will also be relatively easy. It already looks pretty good, but it still assumes that our footage is in ACES 2065-1 and not ACES CG, so we have to change that. Now it looks fine. If we want to use any sRGB images, such as this JPEG, we will need to use our ODT as an IDT to reverse all the color shifts and make it look just as it was outside of the editor. If we now compare these files, they will look identical, apart from the fact that the ACES CG render still preserves a lot more details and substeps in its file, allowing for more control during editing. During export, Resolve also bakes in the ODT settings from the color management tab, so if you want to render an EXR sequence, you will have to turn that off beforehand. If this is your final output and you're rendering to a video format such as MP4, then you want to keep your ODT enabled.